Hello guys, good morning. Welcome to Physics Hub and welcome to our class. Today in this session, we are starting differential equations. So till now we have covered vector, matrices, dimension analysis, and now we are going to start a very broad topic, differential equations. So this will take couple of lectures, okay? But the good thing is this topic is very easy, so you don't need to worry about too much, okay? So without any further ado, let's start today's session. If everything is all right, this topic is very easy, okay? So your CSIR-NET 2024 June answer keys are already out. I hope you have done very well. And what we gonna do? We are going to take sessions for the solution of CSIR-NET 2024 June, maybe subject wise. I will prepare the solution very soon, and we can discuss all the solutions subject wise. For the timing, let's concentrate on this lecture of differential equations. Now, before I start, let me tell you that this course has just started. You can yet join this course. If you utilize this code CSIR, you will get it at 7499, and this course include complete package. You will get video lectures, you get PDF printable notes, topic wise assignments, solved, one-on-one counseling if you require, short notes, test series, Sunday test, mock interview. This Sunday test is going to be very useful for all of you. We will start from the next Sunday, not this Sunday. We will start from the next Sunday. So every Sunday I will design a test which you can give, and you can be very regular in giving test, and that will largely improve your preparation, okay? Now without any further ado, let's start. Okay, we'll start with linear ordinary differential equations of first and second order. So today we'll be covering the first order differential equations, and in the next class we'll cover the second order differential equations. Now there are multiple types in these first order differential equations which we should learn. So let us start with the very basic thing. What do you understand by differential equation? So any equation which involves differential coefficients meaning dy dx, d square y dx square, and such things. So any equation which involves differential coefficient is called differential equation. For an example, you can see different examples of that. We are basically following this content from H.K. Das. I hope all of you have this book by H.K. Das. I have uploaded this book's PDF in the course folder. If you go to the course folder, you can see I have uploaded all the standard textbook for all the subjects, okay, either 1 or 2. These are partial differential equations. Now there are two types of differential equation. One is ordinary differential equation, another is partial differential equation. What is the difference between them? For ordinary differential equation, it involves derivatives with respect to a single independent variable, okay, single independent variable. And for partial differential equation, you will see derivatives with respect to more than one independent variable. As you can see, dy dx it is written, but del square z by del x del y. So whenever you see a function contain only one dependent variable, then we can write, let's say when we write derivative, we will write dfx by dx. On the other hand, if f is dependent on more than one variable, let's say f of x, y, then you cannot write df by dx. You should write del f by del x, okay? So this is the basic difference between an ordinary differential equation and a partial differential equation. Now what is this linear ordinary differential equation? Let's talk about that. And before that, let's try to understand what is order and degree of a differential equation. I think you already know, but let's revisit them. The order of a differential equation is the order of the highest differential coefficient. Just remember this term, highest differential coefficient present in the equation. So for this example, you see L d square q by dt square plus R dq by dt plus q by c is sin omega t. So what is the highest differential coefficient? This d square q by dt square. So this is second order differential equation. For this also, you see in the third example, this is the highest order. So the order of these equations is 2. Degree, what is degree? Degree of a differential equation is the degree of the highest order derivative. Degree means the power the highest derivative has. For example, here the highest order derivative is having the power 1. So this the degree will be 1. Here highest order derivative has degree 1. Here highest order derivative has a power of 2. So this case, for the third case, the degree will be 2. Okay. So I hope you understand these simple things. If you want to write, you can write, guys. This one is important. It may not come NET exam, but it may come in the form of statements, but this is likely to come in your GATE exam and some similar exams. Let me know once it is done, then we will move forward. One thing I would like to mention here, you can see this is d square q by dt square or d square y by dx square dy by dx. So let's say dy by dx. So here this y is known as dependent variable, right? Dependent variable, and with respect to which it is varying, that is independent variable. Y is dependent, x is independent. Y is a function of x, let's say. If this is done, we can move forward. Is this done? Just confirm. Murli, Deep, you guys have come. Next, we'll be discussing linear differential equation. What do you understand by linear differential equation? The definition of linear differential equation is differential equation is said to be linear if it follows the following criteria. Number one, every dependent variable, dependent variable means y. I have already told you. It may be given in the another form, but in general we understand y to be the dependent variable. Every dependent variable and its derivatives dy dx, d square y dx square, they will occur in first degree only. First degree only means the power will be 1. Okay. So if we go to that example, so this is a linear equation. This is not a linear equation because power is 2 here. This is also not a linear equation. Okay. So every dependent variable and its derivative occur in first degree only. And number 2, no products of dependent variables. And its derivatives occur. Example, you can take, let's say dy dx is equals to 1 plus x. Okay, d square y by dx square plus 5 dy dx minus 6y equals to 0, and so on. So this is the concept of linear differential equations. Now let's try to understand the geometrical meaning of the differential equation of first order and first degree. Today we will be covering first order and first degree. Let me know once it is done, then we will go for the geometrical meaning of the differential equation of first order and first degree. If you see, this is a function of d square y by dx square, dy dx and y. For first order, only dy dx will appear. No d square y by dx square will be there. Okay. So let's give the next heading, geometrical meaning we don't have space, we have to manage it here. So let's do one thing. So where is this dx? Okay, what is the geometrical meaning? Geometrical meaning of the differential equation of first order and first degree. So very interesting thing, conceptual thing. Just try to understand it a little bit. First order and first degree means only dy dx will appear. So let f of x y dy dx equals to 0. This is the differential equation of first order and first degree. Be a differential equation of the first order and first degree. Do you understand this line? It may be any differential equation. Let's say dy dx plus y is equals to 0, or dy dx minus y is equals to 0, dy dx plus 1 minus x equals to 0, any kind of form. So we have taken a general form f of x y dy dx. This is the differential equation of the first order and first degree. Now solution of this differential equation, what do you understand by that geometrically? So that is what we will discuss. So let's say, let's take the help of a graph to understand it better. Solution means what? Y versus x, right? This is the meaning of solution. You have function y in the variable of x, that is what solution means. Now let's say we do not know the solution for the time being, so we are taking an initial point. Let's say this point is A. Okay, so we have a point A. Let's say the coordinate of A, it is given x naught, y naught. So if you know x naught, y naught, we can find a dy dx at this point A. So what does this dy dx shows? It gives you a tangent at that point, tangent at point A. Okay, so let's say you get a tangent at this point A. So we are drawing this tangent. Now you can say how we so sure that it will be in this direction. Let's say from dy dx we get it like this. Okay, now what you gonna do, you take a point in the neighborhood of A. So let's say this is the point B. We have taken a point in the neighborhood of A, a point in the neighborhood of A is B. Now let's say B has a coordinate x1, y1. Can you say that? And once you know x and y1, we can put the values of x and y in this expression of f of something equals to 0, and from there we can find out the tangent value at that point, right? And once you get this, this will again give you the tangent. So let's say the tangent is like this, and in a similar manner we can take another point in the neighborhood of B. Let's say that point is C. So once you know the coordinate of C, let's say C x2 y2, then again we can find out the dy dx value at C, that will give you the tangent at this point C. So we can again draw a tangent in this way. Can you draw it or not? So this is a D, and from D we can take another neighborhood point, E, F. So in this way, as you can see, it is tracing out a curve, smooth curve in the xy plane. This gives you the solution y as a function of x. This is the solution you get in this way. Now what you can do, you can start with some other point. Let's say you start from here now, some other point, not from A. Let's say you start from A prime. You will put the value of x and y and you will get a tangent here. Let's say you get a tangent like this. Again you will take a neighborhood point, let's say B prime. It may go like this. You can take neighborhood point C prime. It can go like this. you can take another neighborhood point d prime, you can go like this, and so on. So what is the conclusion here? What is the observation here? If you change the initial point, the solution will change. So depending on the initial point, you will get different curves. So we get a family of curves. Okay. So this differential equation represents a family of curves. Tell me if you have understood the geometrical meaning of this differential equation of first order and first degree. Isn't it interesting? If anyone has any doubt, you can ask. Is it done? Can you move forward? Okay. Look, there are mainly 4 types in the first order and first degree. So we'll discuss each one of them one by one with relevant examples. So linear differential equation of first order and first degree means dy dx to the power 1, first order, first degree. So 4 types of first order and first degree differential equation you will encounter. Firstly, the equations solvable by separation of variables. This is a very strong technique. You will also use it in the quantum mechanical problems. In hydrogen atom problems you will use. Number 2, homogeneous equations. Third, linear equations of the first order, and fourth, exact differential equations. So let us try to discuss them one by one. Firstly, case of separation of variables. The name itself reveals its nature. Here we will separate the variables. Here we have dependent variables and independent variables. So f of y dy, so y related variables, y related terms we are keeping aside, and x related term will keep aside. Okay, so initially let us say you are given dy dx is equals to phi x by fy, and you have separated it in this way. So this one you can do easily. What you gonna do next? Next, you have to take integration on both sides. So f of y dy integration phi of x dx. Then you need to add an integration constant on the right. So this is the way you can solve the differential equation. Okay. Let us take an example. I am giving you that solve e to the power dy by dx is equals to x plus 1, and this arbitrary integration constant can be removed by the initial condition given y is equals to 3 at x is equals to 0. Okay. So how will you do this? E to the power dy dx is equals to x plus 1 and given y equals to 3 at x equals to 0. So e to the power dy dx, first thing which will come into your mind, that take logarithm on both sides. Okay na? So if you take logarithm on both sides, what you get, dy by dx is equals to ln of x plus 1. Now we can use the separation of variable techniques. So y related term will be one side, so dy, and x related term ln x plus 1 dx on the other side. Now you have to take integration on both sides. So take integration on both sides. Okay. So the left hand side is quite simple. Integration of y dy is y, and here you can see this ln x plus 1 is one variable u and multiplied by 1. So u v dx formula you can use. So if you apply this Liot formula, then you can integrate this. Do it by yourself, guys. U integration v dx. So ln x plus 1 should be taken u. So integration of dx is x. So x ln x plus 1 minus du dx is 1 by x plus 1, integration of dx, so x. So x by x plus 1 dx plus c. Now look what we can do here. What happened in my y is equals to x times ln x plus 1 minus, you can just add 1 minus 1 dx plus c. So x times ln x plus 1, you see x plus 1, so integration of dx, so minus x, minus minus plus, plus integration of dx by x plus 1. I am just doing in small steps so that you understand it better. And this is what ln of x plus 1. So ln of x plus 1, if you take common, then you get x plus 1 ln of x plus 1 minus x plus c. Now given condition, use y equals to 3 at x equals to 0. So y at x is equals to 3, sorry, x equals to 0 equals to 3, and hence 3 equals to, if you put x equals to 0, c. So therefore the solution becomes y is equals to x plus 1 ln x plus 1 minus x plus 3. Let's move on. Homogeneous differential equations. This is the second type. So let's say we have a differential equation of this form: dy by dx is equals to f of xy divided by phi of xy. So it may be given in this form. So this equation is called a homogeneous equation if each term of f of xy and phi of xy is of the same degree. Okay. For an example, if I give you a differential equation, let's say dy by dx is equals to 5xy plus 3y square divided by 2x square minus xy. So as you can see, total power x to the power 1, y to the power 1, 1 plus 1, 2, y power has power 2, here x has power 2, xy has power 1 plus 1, 2. So f of xy and phi of xy is of the same degree. Understood? So for such cases, the solution is obtained by putting, look, y is equals to vx. You have done it in your class 12 also, this y is equals to vx, and y, if y is equals to vx, then dy by dx is nothing but v plus x times dv dx, and the rest of the calculation will follow automatically. So if you can identify a given differential equation to be homogeneous differential equation, you will straightforwardly do this transformation: y is equals to vx and dy dx is equals to v plus x dv dx. Okay, and you will simplify. Let me give you a problem now. Give this problem a try. The function y of x satisfies the differential equation given by this with the initial condition y equals to 1, y at x equals to 1 is equals to 3. What will be the value of y at x equals to 3? Try to do it, okay? I'm giving you some time. Is it getting solved? Are you able to do it? What is given to us? X dy dx is equals to this. So, if you see dy dx is equals to y by x ln y by x plus 1. So, we can write it in this way, ln y by x plus 1 divided by x by y, and as you can see, y by x power 1 by power 1, power 1 by power 1, so effective power is 0 here. So, this is a homogeneous form. So, for this we can directly put y is equals to vx and dy dx is equals to v plus x time dv dx. Okay. So, if we put this value dy dx is equals to this, so therefore v plus x time dv dx. If you have solved, you can let me know the answer in the comment section. This is equals to ln y by x. So, wherever you see y, you just replace it with v. Wherever you see x, just replace it with 1. Okay, then other thing will fall its place. So, wherever you see y, you will replace with v. Wherever you see x, you will replace with 1. Okay, then you don't need to look around. Ln y by x, so ln y is v, so ln v plus 1 divided by 1 upon v. No issue. So, v plus x dv dx is equals to v ln v plus v. So, v get cancelled. So, we have x times dv dx is equals to v ln v. So, we can now produce in separation of variable, take v terms at one side, x terms on the other. So, dv by v ln v, this is equals to dx by x. So, it has now come in the separation of variable form. So, you can take integration on both sides. 81 right? Yes, 81 is the answer. Let us see. Look, 1 by v. So, can we not write d of ln v divided by ln v? So, d of ln v is 1 by v dv. So, 1 by v dv we have written as d of ln v is equals to dx by x. So, it is in the form of dx by x. So, what is the integration of dx by x? It is ln x. So, ln x is ln v. So, ln of ln v, this is equals to ln x plus c. Clear? Now, we can put back our v is equals to y by x, ln x plus c, because we have considered y is equals to vx. Now, you see, given y at x equals to 1 is equals to 3, and hence ln of ln y by 3 by 1, so 3, this is equals to ln 1 is 0, So C is equals to ln of ln3. Therefore, we can write ln of ln y by x is equals to ln x plus C is ln of ln3. Too much ln, guys. Now ln we can remove from both sides. So ln y by x is equals to ln is removed. So x plus ln x plus ln3. So ln of x ln3. Okay. So x e to the power x times ln3 हो जाएगा ना, x times ln3 by removing ln from both sides, because this is equals to ln times x ln3. Okay. So from this, what you can write, y is equals to x ln3 and now if you remove, so x times e to the power x ln3, right. So what you have to find out? You have to find out y at x is equals to 3. So y at x equals to 3 is 3 e to the power 3 ln3. So 3 e to the power ln 3 to the power 3. So e to the power ln x is equals to x. So 3 times 3 to the power 3. 3 times 27, 81. Is that clear? Matching with option B. This is a TIFR problem. Huh? This problem came in TIFR. TIFR 2015. Look, if you do systematically, then you will get answer easily. Otherwise, you know. Let's go to the third type of linear differential equation of first order. What is the third type? That is itself called linear differential equation of first order. Let's move on. I hope you have done it. Okay, so linear differential equation of first order, the general form is given by dy by dx plus py is equals to q. This is particularly very important for your exam perspective. This is called the linear differential equation. First order linear differential equation. P and Q are functions of x, or constants, but they are not a function of y. Okay, P and Q are functions of x or constant, but not a function of y. There will be no y related term in these functions P and Q. Now for this kind of equation, if you need to have the solution, you need to find out integrating factor. In short, IF, and the value of the integrating factor is given by e to the power integration p of x dx. What is p? P is the coefficient of y. Whatever coefficient you will see with y, that is p. So once you find out the integrating factor, the solution of the differential equation will take the form this one. You need to remember, integrating factor times y is equals to integration q of x, means whatever staying on the right hand side, multiplied by integrating factor times dx plus integration constant c. Okay. Now what is the purpose of introducing this integrating factor? Integrating factor what it does, it makes a perfect differential. Okay na? Which differential you already know, exact differential it makes. Let us take some problem then. Chalo, let's take a problem. So I'm giving you a problem. Solve x plus 1 dy dx minus y is equals to e to the power x times x plus 1 whole square. This is a differential equation which you need to find out the solution, for which you need to find out the solution. So first of all, what will be our task? Our task will be to transform the given differential equation into the conventional form of dy dx plus py equals to q. So let's see whether we can convert it in that form. So dy by dx, if you just divide by x plus 1, so what you get? 1 by x plus 1 times y is equals to e to the power x times x plus 1. So we have that divided by x plus 1, and from it you can easily see that this minus 1 by x plus 1, because you need to consider a plus, this is your p, and e to the power x by x plus 1, this is your q, isn't it? So what is the integrating factor then? Integrating factor e to the power integration px dx, so integration minus 1 upon x plus 1 dx. Okay, so e to the power minus log of x plus 1, you can also write ln. So in mathematics generally we use log, and when we deal with physics we write ln. This minus 1 is taken above, and e to the power log x is equals to log x, you know, e to the power log x equals to x, so this will become 1 by x plus 1. So once you get the integrating factor, what is the solution? Integrating factor multiplied by y, so 1 by x plus 1, therefore the solution is integrating factor times y equals to integration q of x, so q of x is e to the power x times x plus 1 into integrating factor 1 by x plus 1 dx plus c. Okay, so this will give you y by x plus 1 is equals to integration e to the power x dx plus c, or y by x plus 1 is equals to e to the power x plus c. So in this way you can find out the solution. Now I am giving you a problem which came in June 2017. You just give it a try. The function y of x satisfies the differential equation. This if y at x equals to 1 is equals to 1, the value of y at x equals to 2 is. Let us solve with me. Let's reframe this given differential equation as dy dx plus py. So you can see this is 2 by x y equals to cos pi x by x square. So obviously from here you can say this is your p, this is your q. So the integrating factor will be e to the power integration 2 by x dx. So this is equals to e to the power 2 log x e to the power log x square. So that is x square. Therefore the solution, integrating factor into y equals to integration q of x into integration factor dx plus c. What answer are you getting, guys? A, B, C, D, which one are you getting? X square getting cancelled, so sin pi x by pi plus c, y is equals to sin pi x by pi x square plus c by x square. So let us now put these values, given value y at x equals to 1 equals to 1, that means 1 is equals to sin pi is 0, c by 1 square, so c equals to 1, and hence y is equals to sin pi x by pi x square plus 1 by x square. and that gives you y at x equals to 2 equals to sine 2 pi divided by 4 pi plus 1 by 2 square, so 1 by 4. That is matching with option D. देखो, is it clear? Yes, Deep. Now give it a try. This another problem. Consider a differential equation dy dx plus y tan x equals to cos x. If y at x equals to 0 is equals to 0, y at x equals to pi by 3 is. Can you do this problem? Your first task would be to put it in the conventional form. So dy dx plus tan x times y is equals to cos x. So p is equals to tan x, है ना? So let's calculate the integrating factor. Integration, sorry, e to the power integration px dx. Tan x dx. So what is the integration of tan x? Log of sec x. So this is sec x, and hence we can write the solution. Integrating factor multiplied by y we are writing on this side, is equals to integration q of x integrating factor dx plus c. So y sec x, sec equals to 1 by cos, so x plus c. A you are getting. Let's see. Let us now use this initial condition y at x equals to 0 is equals to 0. So c is equals to 0. So y at x equals to pi by 3 you have to find out, and hence y sec x is equals to x. So we are not comfortable with sec x, so let's convert it into cos x, y by cos x, and hence y at x is equals to pi by 3. Pi by 3 divided by cos pi by 3. What is the value of cos pi by 3? half. Have we done any mistake? X cos x होगा ना? Okay. One by cos x, so x cos x. So pi by 3 cos pi by 3. Pi by 3 into 1 by 2, pi by 6 means 0.52. Option A. Yes. Okay, now do this problem. The solution of the differential equation 1 minus x square dy dx plus 2xy equals to x root over 1 minus x square is given by. Question may come from this section, high chances are there. That is why we are solving multiple problems from this particular part. Solve this and let me know the answer in the comment section. I'll be back soon. Is it done, guys? Okay, so what is given here? Dy by dx plus 2x by 1 minus x square times y equals to x by root over 1 minus x square, isn't it? And hence the integrating factor will be e to the power integration 2x by 1 minus x square dx. So we can write it in this way: e to the power d of 1 minus x square divided by 1 minus x square. So d of 1 minus x square is minus 2x, but here it is plus 2x. So let's take a minus sign. So e to the power minus ln 1 minus x square, ln or log, whatever you want to write, but with base e, ln is better to write. In mathematics it doesn't create much problem. One upon 1 minus x square. Option A you are getting? Yes, option A will be the answer. So I think you have understood, right, this simple technique. We have also solved couple of problems. This is equals to x by 1 minus x square to the power 3 by 2 dx plus c. Now to solve this, what you can do, you can, let's say, put 1 minus x square equals to t, so minus 2x dx is equals to dt, and hence y by 1 minus x square x dx is equals to minus half dt, minus half integration dt by, this is t to the power 3 by 2 plus c, and t to the power minus 3 by 2, so t to the power half, t to the power minus 3 by 2 plus 1 minus half, and this 2 will also get absorbed, and minus sign as well. So this will give you 1 upon root over 1 minus x square plus c. Okay, so option C will come in this way. So option A, option 1. Now there is a special type of this particular differential equation, that is known as Bernoulli's equation. Little bit of modification on the right hand side. So what we have seen in this type, that dy dx plus px is equals to q of x. Now if there is something y to the power n multiplied with q, then this approach will not be effective. We have to take up other approach. So let's try to discuss this special case, differential equations reducible to the linear form. Look, previously we had this equation dy by dx plus py is equals to q. Now instead of this, if you have y to the power n, then how will you do this? This type of equation is known as Bernoulli's equation. So we can reduce this Bernoulli's equation into linear form. Obviously this is non-linear, because as per the definition of linear equation we have written that all the dependent variable and its derivatives will appear in first degree only, but here you see y to the power n, so that makes this equation non-linear. So we need to transform it into a linear equation. For that, what you gonna do, you just divide by y to the power n. Okay, let's say this is equation number 1. Divide both sides of equation 1 by y to the power n and substitute 1 by y to the power n minus 1 equals to z. Why we are doing this? We are doing this just to reduce it into a linear equation. We want to get rid of this y to the power n dependency, that is why we are doing this. So if you divide by y to the power n, what you get? 1 by y to the power n dy by dx plus 1 by y to the power n minus 1 times p, because y was there. This is equals to q, right? Now if you put y 1 by y to the power n minus 1 equals to z, what you get? You get 1 minus n divided by y to the power n dy by dx is equals to dz by dx. Can you write it in this way? Z is equals to 1 by y to the power n minus 1. So dz by dx means derivative with respect to x, right? So it becomes like this. So from here 1 by y to the power n dy by dx is equals to 1 by 1 minus n dz by dx. So this term is done. Let's say this is equation number 2. Equation number 2 becomes 1 by 1 minus n dz by dx plus pz equals to q, or dz by dx plus p times 1 minus n into z. This is equals to q times 1 minus n. Now you can see this is a linear equation, isn't it? Which is a linear equation. And can be solved using the previous method. Let me know if you have understood this technique or not. If you have any doubt, you can ask about this. Let me give you an example. I am asking you to solve the dy by dx is equals to plus xy is equals to x cube y cube. So obviously this is a nonlinear differential equation, and it is in the Bernoulli's equation form. Okay. So let us try to solve this. What will be our first task? You have to divide by y to the power n. Here y to the power n is y cube. So 1 upon y cube dy by dx plus x by y square is equals to x cube. Now what you have to put? 1 by whatever you will see here with x. So y to the power n minus 1, you have divided with y cube. So n minus 1 is y square. So 1 by y square equals to z. So from here dz by dx, what is that value? Y to the power minus 2. So minus 2 by y cube and the derivative of dy dx, derivative di dx. From this 1 by y cube dy by dx equals to minus 1 by 2 dz by dx, and hence if we put it here, minus half dz by dx plus x by y square, so xz equals to x cube, that is equals to dz by dx minus 2xz is equals to minus 2x cube. Okay, so this is now in the linear differential equation form, and as you can see, this minus 2x is p, minus 2x cube is q. So we can write the integrating factor. E to the power integration px dx e to the power minus x square. Okay, therefore the solution is integrating factor into y e to the power minus x square. Here y is z, z is the dependent variable now, so you will write e to the power minus x square into y, in place of y you will write z equals to integration q of x minus 2x cube into integration factor e to the power minus x square dx plus c. So z e to the power minus x square is equals to minus 2 integration x cube e to the power minus x square dx plus c. Now let minus x square equals to t, and therefore minus 2x dx is equals to dt, and that makes z e to the power minus x square equals to integration minus 2x cube. So what we have? X cube dx, you can write it as x square e to the power minus x square into x dx. Okay, so minus 2x dx is dt, x square is t e to the power t dt. Got it? Plus c. Is it clear till now? and this is equals to t e to the power t minus e to the power t plus c. Now put back whatever you have taken. Z equals to e to the power y to the power minus 2 you have taken, z is equals to 1 by y square we have taken, and t is equals to minus x square we have taken. So let's put them back. E to the power minus x square divided by y square is equals to minus x square e to the power minus x square minus e to the power minus x square plus c, and hence 1 upon y square e to the power minus x square is cancelling from both sides, c e to the power x square. So this kind of solution you can get. Tell me guys if you have understood this or not. Let's move forward. One last type is remaining. Let's do that and we'll wrap up the session after that. The last type is exact differential equation. So this is the last case of this first order and first degree. So if you have a differential equation of the form m dx plus n dy is equals to 0 is said to be, look, this particular type you need to remember few things, okay. Differential equation of the form m dx plus n dy is equals to 0 is said to be an exact differential equation if it satisfies the following condition. The condition is del m by del y is equals to del n by del x. This condition needs to be satisfied. Del m by del y is equals to del n by del x. Now the solution for this kind of equation will be integration m dx plus integration n dy equals to c. But there is a small catch here. Here when you consider m, here y is equals to constant. You have to treat y equals to constant, and for n here you need to remember terms of n not containing x. Is it clear or not? it will be clear if we do a problem. So n may be a function of x and y. So you will consider here only those terms of n which does not contain x. Giving you a problem. Solve this particular differential equation. 5x to the power 4 plus 3x square y square minus 2xy cube dx plus 2x cube y minus 3x square y square minus 5y to the power 4 dy equals to 0. So you can see this is in the form m dx plus n dy. So first task would be to check this following condition: del m by del y is equals to del n by del x. Once this criteria is satisfied, we can say that it is an exact differential equation. Once you are confirmed with that, you can write the solution directly in this form. In the first integral of m dx, you will treat y to be constant, so that will be used while doing the integration. And when you will write n, you will consider those terms only which does not contain x. So if this is the case, so 2x cube y, it is containing x, so you will not take this term. 3x square y square, this is also containing x, so you will not consider this term. 5y to the power 4, this is the term which does not have x, so you will only consider this term. Am I clear? Here as you can see, m is equals to 5x to the power 4 plus 3x square y square minus 2xy cube. And n is equals to 2x cube y minus 3x square y square minus 5y to the power 4. And hence del m by del y. Del m by del y is 6x square y minus 6xy square. Del n by del x, 4x square y minus 6xy square. 4 क्या होगा, 6 होगा ना. And since we have got del m by del y is equals to del n by del x, the given equation is exact. Correct? Once you are sure about it, we can now write this m dx plus n dx is equals to c. Here n not containing x, so let's write integration 5x to the power 4 plus 3x square y square minus 2xy cube dx plus n not containing x, so minus 5y to the power 4 d, अच्छा m dx plus n dy होगा ना. This is equals to C. So x to the power 5 by 5, this is y should be treated to be constant, so x cube by 3, so x cube y square minus x square y cube minus y to the power 5 equals to C. Yes, Murali. Understood? Okay, let me just give you a list of some of the exact differential equations, then we'll wrap up the session. List of exact differential equations. Number 1, you already know it, d of y by x, x square x dy minus y dx. D of log of xy, x dy plus y dx divided by xy. Number 3, d of xy, that is well known to you, x dy y dx. D of tan inverse y by x, x dy minus y dx divided by x square plus y square. You don't need to remember this, I am just showing you, okay? Don't take extra load, don't overburden yourself. This is just you go through once, it is not used in your examination. Only this one may be used, no, it's widely used, and this one. These two are widely used, otherwise other exact differential are not used so much. Okay guys, so it's the time to wrap up the session. Everybody, you will like the video, okay? Mathematical physics we are taking on YouTube, but for other subjects it will not be available on YouTube, okay? Sunday, tomorrow, Sunday is an off day. We'll take the next session on Monday 8 AM, okay? Till then, bye bye, take care, see you guys in the next class. Have a great weekend, guys. And we'll start the Sunday test from the next Sunday, not this Sunday, okay? Bye.